Welcome to the electrolytic cell summary video. We will start with what it is about. So the first thing is that electrochemical cells or electrolytic cells is when you convert the electrical energy into chemical energy. So you are putting energy into the system to store it in forms of compounds, etc. Now, the electrolytic cells are non-spontaneous and endothermic. It's like the opposite of the galvanic cells. We have to use a direct current from a battery or a cell, and we use carbon electrodes. That is those bars down here. These bars. All right. So what was that? All right. We use carbon electrodes because they're unreactive, and you can reuse them multiple times for separate reactions. So. Right, so if we take a look at the standard electrolytic cell, let's just use a bit of logic to see what is happening over here. So we're starting with our battery. Now we look in terms of the electron direction, not the conventional current direction. So this is a cell, the short end is negative, so the electrons will move down this way, causing that electrode to be negative. So the negative electrode will be on the side of the battery. That is the negative side of the battery. Makes sense. So if I were to swap this out, as we look here, looking at, I just swapped this out, let me show you quickly. I swapped the battery around, so that means then that this will no longer be the negative side. Oh no. Let's see if I can get that out there. Then this side will be the negative side because it's on the side of the negative side of the battery, right? Okay, so going back to how we started, we have the negative side of the negative electrode over here. So what happens is in the solution, it can either be an aqueous solution or something that is melted, a compound that's melted. So there's ions, or in the solution there's ions. So either it is a melted substance or something dissolved in water. Right, just some example, we have a solid PbBr2, which is insoluble in water. But if we melt it down, heat it to a very high temperature, and put it have it as a liquid, we can actually cause certain reactions to happen. And the same for what we usually used to. We take copper chloride, we chuck it in water, and it just dissociates into Cu2 plus and Cl minus ions. So it can be either or. So taking a look at this negative electrode, and we're going to take this example here of the PbBr2, which has been melted. So we have Pb2 plus ions and Br minus ions in solution. Now we know this is the negative electrode, and the other one must therefore be the positive electrode. Where will the Pb2 plus ions be attracted to? Will they not go towards the negative because they're opposite charges? So the Pb2 plus will go to the negative electrode, forming I'll tell you what it forms just now. And the Br minus ions will gravitate towards the positive electrode. But if we take a look at what happens here at the negative electrode, we have, I'm going to rub this out here, we have Pb2 plus receiving electrons from that negative electrode, forming a lead as a solid. So you'll actually, on this carbon electrode, you'll pack on lead as a solid. It will actually pack on the surface of this electrode. So what is happening? We have lead going from 2 plus to lead going to a 0. So there is a reduction happening here. And remember our red cat from the previous video, the red cat little acronym or whatever. So where reduction takes place, that is the cathode. So this therefore is the negative is the cathode. Now in the galvanic cells, it's the opposite way around, as positive, but red cat holds true for both, and oxan, obviously, they holds true for both systems, electrolytic cells and galvanic cells. So we have the gist of that. So obviously the Br minus ions will gravitate or go to the oxan side, the anode side, negative ions go to the anode, and they're the anions in this case. And they will donate that electron, and it will cause a circuit. The electrons will flow, or the charge will flow in this sort of clockwise direction in this case. As the electrons move like that in the wire and the anode and cathode, and then the charge will be carried over that by the ions. So if you look at the anode over here and the Br minus going there, we have Br minus ions giving away an electron, or two electrons like this. So this will have a negative charge over here going to a positive charge. So that's an increase in the oxidative state, which is then oxidation. So Br minus undergoes oxidation to the Br2 there. So let's write down the two half reactions and get the net reaction of the this reaction taking place. So by our anode, we have the anode, we have the cathode, and we should actually talk in terms of reduction and oxidation, but it's like, yeah, let's just do that. Reduction, oxidation, half reactions, and then we have our net reaction. So where's reduction taking place? Red cat. So at the cathode, we determine by knowing it's a negative electrode. Negative attracts that Pb2 plus. We write the equation here, we see, okay, that's reduction, so therefore this must be the cathode. Right, and that's red cat, and because it's the cathode, that's where reduction, well, we know the reduction takes place, therefore it is cathode. So if we look at reduction, it will be Pb, I'll write it down quick. So the lead accepts two electrons and precipitates out as a solid. And in the oxidation half reaction, we have this over here, as you see there, and then we look at the electrons. As we know from grade 11, they cancel out there, so we just write the net reaction by adding everything on the left and adding everything on the right. There we go. Same amount of lead atoms on the left, same amount of bromines on the right, and the total charge on the left will be a +1, and on the, sorry, there's two of the negatives, so it'll be a 0 and a 0 on the right. So there we go, there's our net reaction, and it works out, our net cell reaction over there. Right, so let's go to the next thing we can look at, which is the electrolysis of water. Right, so water is a poor conductor of electricity. So we can't just put water in and then pump current through it and expect it to work, because it's kind of like a insulator. So what we do is we put it in an electrolyte of sulfuric acid to increase the concentration of ions so that the reaction can actually take place. So our electrodes are made of carbon or platinum because they're inert, they don't react, and we put a current through the system. So taking a look at this battery, which side is the negative side? Negative, so the electrons will go in this direction. We have then a negative electrode over here, and then on the right we have the positive electrode. Now, don't memorize things like this. We just take a look at what is in solution, and then we can decide what is being reduced and oxidized, and therefore we know what the cathode and anode is, and therefore we can say what is the anion and the cation. So let's take a look. Right, so what happens is reduction, which is this water is being reduced to H2 and 2OH minus, and by the oxidation of reaction would be water being oxidized to oxygen and 4 hydrogen ions, and there's a +2 electrons over there. So reduction takes place at the red, reduction is at cathode, and oxidation takes place at anode. Meaning that the cathode there will be the negative electrode because it's donating it to the water over here, and then therefore that will be positive. And if you add these two together, we get, sorry, I saw a mistake here. We have a +4 charge on the right. I mean, if we write this like this, right, we have a +2 charge on the right, and on the left we have a 0 charge. So there's a problem. I need 4 electrons, right? And if we add this together, we end up with this, but then we see that this then forms 4 waters. So what actually happening is it subtracts off here, so we end up with a net reaction of 2H2O. The liquid goes to 2H2 as a gas plus and O2 as a gas. Right, So that's how we get that. And how do you test for hydrogen? We use that, you light a match near the test tube that contains hydrogen gas and makes a popping sound, correct? And to test for oxygen, so a little mini explosion. And for oxygen, we take a glowing splint of wood and it will ignite if you put it by the mouth of the test tube. So we have burning splinter. So to test for oxygen, it's a burning splinter and it will ignite if you put it by the mouth of the test tube. And for hydrogen gas, a small pop or explosion will be heard from a burning match. That's how you test for those two. And remember, carbon dioxide, you test by, the positive test for carbon dioxide is by bubbling it through clear lime water and it turns milky. Those are like the three gases we usually test for. All right, so electrolysis of ionic solutions. When a salt is dissolved in water and we put a current through the solution, the positive ions of the salt will compete with water, as you saw in the previous example, to gain electrons, being reduced at the negative cathode. And same for the negative ions, will compete with water also to lose electrons, being oxidized at the positive anode. So there's a means to decide when it is either the positive ion or the water that will gain preference at said electrode. So let's take a look. Right, so the way we can determine if the positive ions will rather be reduced than the water molecules is that the positive ions with a reduction potential greater than -1 will have preference, but positive ions less than -1 will cause that the water is reduced and not the positive ions themselves. But it can still happen under certain situations, like if you have a high concentration, the electrode type you use, and high pH. But generally speaking, if the reduction potential is less than -1, then the water molecules gain preference, and we end up with a situation up here where the water gets reduced instead of the positive ion. All right, so let's take a look at the negative ions. They compete also with water to lose electrons to the anode, to be oxidized at the anode. So how do we determine this? We look at which negative ions are the stronger reducing agents from our table. So for example, Br minus and your iodine ions will always be oxidized. Right. Another way we can look at it is if we looking at the positive ions competing with water to gain electrons at the negative cathode, we can look at the E naught values or the reduction potential values to see who has the highest value between water, H2O, and that positive ion. The one with the highest value gets reduced at the cathode, and the opposite is true for the negative ions competing with water. The one with the lowest E naught value will be oxidized at the anode. Right. So if the water has the lowest E naught value, the water equation, then the water will be oxidized. But if the negative ion has lower E naught value, it will be oxidized at the anode. Right, so here are some electrolysis questions you can be asked in exams. I'll do all of them and we can take a look at how they work. So let's look at the first one. It will be let's look at all of them quickly. The electrolysis of a copper chloride solution. We have the electroplating of an iron spoon with silver, electro-refining of metals, purifying metals, having them to a higher percentage, and then there's recycling of aluminium and the production of chlorine gas in the chloralkali industry. So let's start with number one. Yeah, I'll draw a picture quick and let's carry on. Right, so for the electrolysis of an aqueous solution of copper 2 chloride, we have a container, we have water, we have copper, let's zoom in a bit here. We have copper chloride ion, copper 2 plus ions, chlorine ions. We have two of these electrodes, they are carbon, and then we have wire, and a power source. Let's make positive left this time. Okay, before we carry on, let's use some logic. Negative side, therefore, negative side. Positive side. next thing, because it's a negative electrode, we have the positive ions going to the negative electrode. So we have Cu2 plus gaining electrons going to a copper solid. And then we determine that is a reduction. We've got 2 plus, plus 2 going to a 0. That's a reduction. So that is our reduction. And reduction is a red cat. Remember our red cat. So this will be our cathode. And then our chlorine ions are going to go that way, which means then that will be a Cl minus, giving off an electron. But we've got 2 of these, so we need